In the silent, unending theatre of the cosmos, countless dramas unfold on scales that defy human comprehension. Galaxies, those colossal islands of starlight and dust, are the principal actors in this grand cosmic play. For eons, they drift, they spin, they live, and they die. Sometimes, in the unfathomable emptiness between them, their paths converge, drawn together by the invisible hand of gravity. What follows is a spectacle of creation and destruction. A gravitational waltz that spans 1 billion years, where stellar metropolises tear one another asunder their elegant spiral arms, unraveling like cosmic streamers. These collisions are the universe's most violent and beautiful events, forging new generations of stars from the wreckage of the old. And for decades we believed we had a perfect front row seat to just such a celestial ballet. Out in the faint constellation of Pisces the Fishes, some 100 million light-years from our own quiet shore, lies a breathtaking spiral of suns known as NGC 105. Through the lenses of our most powerful telescopes, it has long appeared to be a textbook case of galactic interaction. Its form seems distorted, its structure disturbed, as if locked in a gravitational tug-of-war with a nearby companion. It was a story we told ourselves, one that fit the visual evidence. A story of a cosmic dance, of a beautiful, violent merger in progress. But the universe is a master of illusion. It plays tricks with light and distance, with perspective and time. The story of NGC 105, as we are now beginning to understand, is not one of collision but of profound deception. The truth, hidden in the subtle shifts of ancient starlight, reveals a narrative far stranger, more mysterious, and more challenging to our understanding of how these immense structures evolve. This is the tale of a celestial mirage, of a phantom collision, and the exposure of a galaxy whose true shape defies all our expectations. To understand the depth of this cosmic misinterpretation, we must first journey back in time to an era of nascent astronomy. Long before we knew of island universes scattered across the void, our ancestors looked up at the night sky with unaided eyes, seeing only a smattering of faint fuzzy patches among the stars. The great Andromeda, our nearest major neighbour, was simply the little cloud to the Persian astronomer Al-Sufi a millennium ago. These were mysteries, celestial smudges on the lens of the firmament. With the invention of the telescope in the 17th century, our view sharpened, but the confusion only deepened. Observers like Charles Messier, a French comet hunter, meticulously catalogued these nebulae to avoid mistaking them for the transient comets he so desperately sought. His catalogue, a foundational text of deep sky astronomy, listed spiral-shaped wonders like M51, the Whirlpool Galaxy, as mere faint smudges, their true nature utterly unknown. Even the colossal telescopes of the 19th century, like Lord Rosse's Leviathan of Parsonstown, could resolve the twisting arms of these objects, but their identity as independent star-filled realms like our own Milky Way remained a subject of fierce and protracted debate. It was in this environment of burgeoning discovery and profound uncertainty that our subject NGC 105 was first recorded. On an autumn night in 1884, the French astronomer Édouard Stéphan, using a powerful new reflecting telescope at the Marseille Observatory, spotted a faint, elongated haze in the constellation Pisces. He noted its position, its dimness, its ghostly appearance, and it entered the growing astronomical record as Object 105 Inches, the new general catalogue of nebulae and clusters of stars. For nearly half a century, that is all, it was another faint fuzzy, a single data point in the great celestial census. Then in the 1,920 seconds, Edwin Hubble revolutionized everything. Using the Hooker telescope at Mount Wilson, then the largest in the world, he measured the distances to these spiral nebulae, proving conclusively that they were not clouds of gas within our own galaxy, but were in fact island universes, staggering collections of billions of suns lying millions of light-years away. The scale of the known universe exploded in an instant. Our Milky Way was not the entirety of creation, but one of countless specks in an ocean of unimaginable vastness. With this new understanding, astronomers turned their attention back to the catalogued nebulae with fresh eyes. NGC 105 was re-examined, photographed with more sensitive plates, its light dissected and analysed, and what the images showed was tantalising. It was a beautiful spiral seen nearly edge-on, its glowing central bulge and delicate arms traced by dark lanes of dust. But there was something else. Just adjacent to it in the sky, a smaller, more compact galaxy, PGC 1544, seemed to hover menacingly. More importantly, NGC 105 itself did not look pristine. Its arms were not a perfect symmetrical pinwheel. One side appeared warped, stretched, pulled out of shape as if distorted by the gravitational influence of its apparent neighbour. The conclusion seemed obvious, almost inescapable. Here were two stellar systems clearly in close proximity. One was visibly disturbed, its structure bearing the classic hallmarks of tidal disruption, the stretching force of a massive nearby object. The narrative wrote itself: we were witnessing a galactic merger, a slow-motion collision that had been unfolding for millions of years. NGC 105 became a poster child for this cosmic process, its image used in textbooks and presentations as a clear example of how galaxies interact, disrupt, and eventually consume one another. The evidence was right there, a snapshot of celestial violence frozen in time. It was a compelling story, and for a very long time we believed it. The illusion was rooted in a fundamental challenge of astronomy. The universe is a three-dimensional space, but our view of it is projected onto a two-dimensional canvas, the sky. Imagine standing on a dark, desolate coast on a foggy night, looking out over an immense black ocean. In the distance, you see the faint, glowing mast light of a ship. A few moments later, another light appears, seemingly very close to the first. The 2 points of light begin to move together, their glows merging in the haze. From your limited perspective on the shore, you would construct a narrative. You would assume these two vessels are near each other, perhaps traveling in convoy or maybe even on a collision course. You might perceive a drama unfolding, a relationship between the two lights based entirely on their apparent proximity on your field of vision. Now imagine the fog slowly begins to clear, the air clarifies and your perception sharpens. You suddenly realize that the first light belongs to a small fishing boat just a few hundred yards offshore. The second brighter light, however, is not a nearby vessel at all. It is the powerful beam of a massive supertanker on the distant horizon, many, many miles further out to sea. They were never interacting. They were never close. Their apparent rendezvous was a complete fiction, an artifact of perspective, a trick of the vast empty space between them. The drama you had imagined simply evaporates, replaced by a profound sense of the true scale of the ocean before you. For decades, astronomers looking at NGC 105 were like that observer on the foggy shore. Our telescopes, for all their power, gave us a flattened, hazy view. We saw two lights in the cosmic ocean that appeared to be interacting, and we built a story around that perception. The warped shape of the foreground boat, NGC 105, seemed to confirm the powerful influence of the distant supertanker. But we lacked the one crucial piece of information: depth. We had no reliable way to pierce the fog to measure the true staggering distance that separated these two celestial objects. The collision was an illusion born from the simple yet profound act of cosmic alignment, a chance superposition of two galaxies that in reality are lonely voyagers passing in the infinite night, separated by a gulf far wider than we could have initially imagined. The tool that finally lifted the cosmic fog that allowed us to perceive the third dimension of the universe was not a lens but a prism. It was the science of spectroscopy, the art of breaking light down into its constituent colors, its rainbow spectrum. Embedded within this spectrum are dark lines like a celestial barcode. These are absorption lines created when specific elements in a star's atmosphere absorb certain frequencies of light. Each element has a unique, unchanging spectral fingerprint, but this fingerprint can be shifted. In the 1,910 seconds, an astronomer named Vesto Slipher, working tirelessly at the Lowell Observatory in Arizona, made a baffling discovery. While analyzing the light from the so-called spiral nebulae, he found that their spectral lines were almost all shifted towards the red end of the spectrum. This phenomenon, known as redshift, is a consequence of the Doppler effect, the same principle that makes an ambulance siren sound higher in pitch as it approaches you and lower as it moves away. A shift towards red means the source of light is receding from us. And Slipher found that not only were these nebulae moving away, but the fainter and presumably more distant ones were moving away faster. This was the critical insight that Edwin Hubble later synthesized into his landmark law, the universe is expanding, and the speed at which a galaxy is receding from us is directly proportional to its distance from us. Redshift therefore became our cosmic yardstick. By precisely measuring how far a galaxy's spectral barcode has been shifted, we can calculate its recession velocity, and from that we can deduce its distance. It is this technique that finally allowed us to measure the true gap between the ships in the night NGC 105 and its apparent companion. In the late 20th and early 21st centuries, a new generation of telescopes equipped with exquisitely sensitive spectrographs turned their gaze back towards this familiar pair in Pisces. Astronomers painstakingly collected the faint light from both galaxies, photon by photon, over many long nights of observation. They focused the light into their instruments, spreading it out into its constituent colors, searching for that crucial barcode. The spectrum of the smaller companion galaxy PGC 1544 was analyzed. Its redshift was measured, and the calculation was performed. The result was staggering. It indicated the galaxy was receding from us at a tremendous velocity, placing it far, far away in the cosmic depths. Then they analyzed the light from our primary subject NGC 105. Its spectral lines were also redshifted as expected, but the magnitude of its shift was dramatically smaller. The numbers were unequivocal, the conclusion inescapable. NGC 105 is located roughly 100 million light-years from Earth. Its supposed partner, the galaxy we thought was gravitationally mauling it, is actually more than 500 million light-years away. They are separated by an abyss of 400 million light-years of empty space. That is a distance more than 15 times the size of our own local group of galaxies. They are not interacting, they are not merging, they likely have never even been aware of each other's existence. The collision was a phantom, a ghost story born of a trick of perspective. The grand narrative of a cosmic smash-up so compelling for so long dissolved into nothing. This revelation was a triumph of the scientific method, a testament to our ability to overcome perceptual bias with hard data. But it also presented astronomers with a profound and immediate new puzzle. If NGC 105 is not being torn apart by a neighboring galaxy, then why does it look so strange? Why are its spiral arms so lopsided, so warped and asymmetrical? The evidence of its disturbance is written across its face in stars and gas. If the prime suspect has been exonerated, what is the real cause? The exposure of the collision illusion did not end the story. It merely revealed that we had been reading the wrong book all along. The real mystery of NGC 105 was only just beginning. To grapple with this new enigma, we must first appreciate the sublime order that galaxies are supposed to follow. Edwin Hubble, in his quest to classify his newfound island universes, created a system that is still in use today, known as the Hubble tuning fork. On one branch, he placed the elliptical galaxies, smooth, featureless, egg-shaped agglomerations of older, redder stars. On the other two branches, he placed the spirals. There are the regular spirals, like Andromeda, with arms coiling directly from a bright central nucleus. And there are the barred spirals, like our own Milky Way, where the arms emerge from the ends of a brilliant elongated bar of stars that straddles the galactic core. It is a system of cosmic taxonomy, a way of imposing order on the chaos of the heavens. Within this framework, NGC 105 is classified as a spiral galaxy, and yet it conforms poorly to the ideal. Pristine, undisturbed spirals exhibit a beautiful, almost mathematical symmetry. Their arms are graceful, well-defined and balanced. NGC 105, by contrast, looks like a damaged vinyl record warped by heat. Its stellar disk is bent into a subtle but unmistakable shape. Its arms are wispy and ill-defined on one side, while appearing more tightly wound and prominent on the other. Something has twisted this colossal city of stars, applying a torque that has bent its very structure. With the collision hypothesis now defunct, scientists had to search for other, more subtle culprits capable of inflicting such large-scale architectural damage. One of the leading alternative explanations is a process as gentle as a breeze, and as powerful as a hurricane ram pressure stripping. Galaxies do not exist in a perfect vacuum. The vast spaces between them, particularly within clusters of galaxies, are filled with a superheated, incredibly tenuous gas called the intracluster medium. While this medium is millions of times less dense than the air we breathe, a galaxy moving through it at hundreds of kilometers per second experiences it as a significant headwind. Imagine a runner with long, flowing hair sprinting through a misty morning. As they surge forward, the air resistance, the friction from the mist, pushes their hair backward. It streams out behind them, its shape dictated entirely by their motion through the surrounding medium. Ram pressure stripping does something similar to a galaxy. As the stellar metropolis plows through the thin intergalactic gas, this cosmic wind pushes against the galaxy's own supply of cool gas and dust, the raw fuel for future star formation. The stars themselves, being massive and compact, are largely unaffected, but the diffuse clouds of gas, the lifeblood of the spiral arms, are not. They are pushed, compressed, and ultimately stripped away, trailing behind the galaxy like a ghostly wake. This process could elegantly explain the lopsided appearance of NGC 105. If the galaxy is currently moving through a denser than average patch of the intergalactic medium, the side of the galaxy facing into the wind would experience intense pressure. This could trigger a burst of star formation on the leading edge, making its arms appear brighter and more tightly wound. Simultaneously, gas on the trailing edges would be stripped away, leaving the arms on that side looking faint, wispy, and diffuse. The entire gaseous disk could be warped and bent by this relentless pressure, creating the subtle shape that is so clearly observed. In this scenario, the perceived damage to NGC 105 is not from a violent collision, but from a long, slow, attritional battle with its invisible environment. It is a story of cosmic erosion, not cosmic impact. Yet there is another, perhaps more ghostly possibility. The scars we see on NGC 105 today might not be from a current event at all, but rather the lingering phantom of a much older, more intimate encounter. The universe is a cosmic food chain, and large galaxies like NGC 105 grow by consuming their smaller neighbors. Over its billions of years of existence, it has likely cannibalized countless dwarf galaxies, tiny satellite systems that strayed too close and were shredded by its immense gravitational pull. While a major merger with a large companion is a spectacular transformative event, the ingestion of a small dwarf galaxy is a more subtle affair. It is less a collision and more a slow, inexorable process of dissolution. The dwarf galaxy, caught in the gravitational well of the larger spiral, is stretched and pulled apart, its stars spilling out into long, looping streams that wrap themselves around the victor. For a time, these stellar streams, the ghost of the consumed victim, remain as distinct features orbiting within the larger galaxy's halo. But over hundreds of millions of years, these streams mix and phase, their energy and momentum being absorbed by the main galactic disk. This absorption is not a gentle process. It is the cosmic equivalent of indigestion. The gravitational energy of the dead dwarf galaxy can perturb the primary disk like a stone dropped into a placid pond. Ripples of disruption can spread through the spiral arms, causing them to warp, bend, and thicken. A small satellite galaxy plunging through the disk from a high angle could easily create the exact kind of shaped warp we observe in NGC 105. What we are seeing in this interpretation is not an ongoing fight, but the ancient evidence of a murder. The warped disk of NGC 105 is a memorial, a gravitational scar left behind by a long-devoured companion whose stars now mingle anonymously with the trillions of others in their new home. The culprit isn't the distant galaxy we see today, but a ghost that has long since vanished from sight. There remains a third class of explanations, one that looks not to external forces but to the internal dynamics of the galaxy itself. A stellar metropolis is not a solid, rigid body. It is a complex, dynamic system of gas, dust, and stars, all swirling around a common center of gravity where a supermassive black hole millions of times the mass of our Sun resides. Instabilities can arise from within. The galactic bar, that elongated structure of stars at the center of many spirals, can itself be a powerful agent of change. As this bar rotates, its gravitational influence can create resonances throughout the disk, channeling gas inwards to feed the central black hole and simultaneously flinging stars outwards into new warped orbits. It can act like a giant rotating sprinkler, creating and shaping the spiral arms. If the bar itself is not perfectly flat but has its own buckle or warp, it can transmit this distortion throughout the entire stellar disk, bending it into the shapes we see. Furthermore, violent bursts of star formation, perhaps triggered by one of the previously mentioned mechanisms, can have a profound architectural effect. When thousands of massive, brilliant blue stars are born at once, their intense radiation and powerful stellar winds can blow enormous superbubbles in the surrounding interstellar gas. When these stars eventually die in cataclysmic supernova explosions, the combined shockwaves can be powerful enough to physically alter the structure of the spiral arms, creating the lopsided and chaotic appearance that first led us down the path of the collision illusion. In this view, the strange shape of NGC 105 is a self-inflicted wound, a consequence of its own turbulent, violent, and vibrant life. So, what is the fate of this enigmatic galaxy? This celestial spindle that tricked us for so long? Its future will be dictated by whichever of these stories is true. If it is indeed battling a cosmic headwind, it will continue to be stripped of its precious gas. Its star formation will slowly dwindle and then cease altogether. Over billions of years, its brilliant blue spiral arms will fade, its young stars will grow old and red, and it will transform into a passive, anemic system, a red and dead galaxy, a shadow of its former vibrant self. Its journey will be one of slow starvation. If its shape is the ghost of a past merger, then its future is one of slow settling and relaxation. The gravitational ripples will eventually dampen the warp, and its disk will gradually smooth out, and it may, over an almost unimaginable timescale, regain some semblance of symmetry and order. It will be a quiet future, a long and slow recovery from ancient trauma. And what of its relationship with the distant galaxy, PGC 1544, the accidental co-star in this cosmic drama? While they are separated by an immense gulf today, the universe is not static. The slow, inexorable expansion of the cosmos is the overarching theme, but on local scales, gravity can still win. Galaxies and clusters are still pulling on one another. It is not impossible that over the course of the next several billion years, the cosmic dance will bring these two lonely voyagers together for real. Perhaps in the far distant future, the illusion will become reality. The phantom collision will be replaced by a genuine one, and the descendants of humanity, should we survive, might look out into the Pisces sky and witness the very spectacle we once mistakenly thought we were seeing today. The story of NGC 105 is more than just an astronomical curiosity. It is a profound parable about the nature of science and perception. It reminds us that the universe does not always present itself to us clearly. Our senses, and even our powerful instruments, can be deceived. We build narratives based on the evidence we have, but these stories must always be held provisionally, ready to be dismantled and rebuilt in the face of new contradictory data. The journey from the collision hypothesis to the deeper, more complex puzzle of its true nature is a perfect encapsulation of the scientific process itself, a relentless peeling away of layers of illusion in search of a more fundamental truth. It also speaks to our own place in this vast cosmic arena. From our tiny, fragile vantage point, we look out across distances so immense that light itself, the fastest thing in creation, takes 100 million years to cross the gap. Across that chasm, we see a city of 100 billion suns, and we try to understand its history, its present, and its future. We are detectives in a cosmic cold case, sifting through ancient photons for clues to events that happened before our species even existed. The fact that we can even begin to piece together such stories is a testament to the power of human curiosity and intellect. The illusion of NGC 105 forces us to confront the humility of our perspective. It demonstrates that what appears to be true may only be an accident of alignment, a chance superposition in an incomprehensibly vast and deep cosmos. The universe is under no obligation to be simple or to conform to our initial expectations. Its beauty lies not just in its elegant symmetries, but in its perplexing anomalies, its challenging asymmetries, and its profound capacity to surprise us. NGC 105. The galaxy that defied expectations is not just a warped spiral of stars. It is a beacon reminding us to always question what we see, to seek the hidden dimension, and to never stop looking for the truth that lies just beyond the fog of our own perception. The play is not over. The theatre is infinite, and the greatest discoveries are still waiting in the dark.